At the end of Unit 10, only 4 lessons in this unit, so this is Unit 10, Lesson 4. Today we're going to talk about a laboratory procedure called titration. Okay, so the intention is going to be to use the results of a titration to determine the concentration of an acid or base. Okay, so fair warning, little mathy today, not too bad, but there is some. So definitely take a moment and answer these questions here, these do now questions, because this is all very relevant to what we're doing today and foundational to understanding the new material. Okay, so please pause it right here and try these out. I will warn you, number 3 is pretty tricky. Okay, so 1 and 2 you should definitely get and look up if you don't know off the top of your head. Number 3, try your best on that one. Okay, so hopefully you did these. Number 1, how many liters is 250 milliliters? Well, remember, when you're going from milliliters to liters, right, there's 1,000 milliliters in 1 liter. So, right, you want, from milliliters to liters, you want to move the decimal to the left 3 spaces. So 1, 2, 3, right? So it's going to be 0.25, still bad at this, liters, okay? So that's going to be key here because some of these sometimes you're going to want to convert. The question might give you milliliters and you're going to want to use liters, okay? And you'll see why you're going to want to use liters in question number 2. So the equation for molarity, which is in your reference table on the very back page, okay? Molarity, which is the capital M, stands for molarity, is equal to, nope, that's not what I wanted, is equal to, try that again. And remember, molarity is a measurement of concentration, right? So it's the amount of particles in a volume. So the equation is moles per liter. Okay, so the number of moles in 1 liter, that's molarity, and that's how you calculate it, right? If you have 2 moles in 1 liter, the molarity is 2 divided by 1 is 2. Okay. This last one here, what is the concentration of H+, so hydrogen ions, in a 2 molar sample, 2 molar, that means 2 moles per liter, right, of H2SO4. Now, for a simpler acid, it's always the same. It would be 2 molar. However, check this out. See how there's a 2 next to that H? That means for every mole of H2SO4, when it dissociates in water, you're actually going to get 2 moles of hydrogen. So it's a little tricky here, okay? So the answer for this is actually 4 moles, or 4 molar, right? Because it asks for concentration. So 4 molar, that's the concentration. So that's because in each molecule of H2SO4, there are actually 2 hydrogens, okay? So in a 2 molar sample, so if I have 2 moles of this, right, and I put it in water, and the hydrogen, I actually get 2 out of every 1, it's going to double it up, okay? So this is going to be important later in this lesson, okay? All right, so let's get into it. So acid-base titration. So let's say maybe you started teaching at a theater arts high school 5 years ago, and you walk into the back room, and there's just a bottle that says dilute HCl. This actually happens. Actually happened more than once to me. It's just, okay. Actually, I had one bottle that just said danger acid, right? It's like, okay, what acid? How dangerous, So, if you have a bottle of acid that's mislabeled or just very general, when it says dilute, we don't know how dilute that is, right? We don't know what the concentration is. Right, a concentration, if you give a number, it's very specific and we can work with that. If you just say dilute, I don't know what that means. Okay, but there's no one around to tell me. The person who made it is gone. I don't know where they are. So what do we do? Well, if you found it, hopefully, you would tell me. But if I found it, what I would have to do to know the concentration is an acid-base titration. Okay, so a titration is a method for determining an unknown concentration of an acid or a base by using an acid or a base with a known concentration. Okay, so we're going to play a little trick here. in order to figure out, right? So pretend we have this unknown, I have this bottle of HCl, it says dilute HCl. I don't know the concentration, but I can figure it out, okay? So here's the general way this goes about. So we know the volume of the unknown acid, in this case, acid or could be a base, right? We know the volume because I have, I can measure that. I have the liquid, I can measure it in the graduated cylinder and come up with the volume. Cool. Then I want to put an acid-base indicator in there. All right, that's going to be important in a few moments here. Okay, so if it's an acid and I put the acid-base indicator in, the indicator should tell me that it's an acid by turning whatever color it does. Okay, but I still don't know what the concentration is. All right. Now I'm going to take an acid or a base, and it's going to be the opposite, right? So if I'm trying to figure out the concentration of an acid, then I'm going to use a base. If I'm trying to figure out the concentration of a base, then I'm going to use an acid. So it's always going to be the opposite, right? And what you do is you take an acid or a base, the opposite one, of known concentration, so something you know, maybe you made it in the lab or you already had it sitting around, and then you slowly add it to the unknown acid or base using what's called a burette. Looks like this. Okay, so it's actually much longer than this, right? It's a very tall, it's probably like, I don't know, like 2 feet long glass tube. But what it does is it allows you to drip in the acid or base very slowly. All right, so let's just say we're trying to figure out the concentration of an acid. So I would put base in here so I can drip in the base of a known concentration very slowly into my unknown acid. That's important because you don't want it to go too fast, because as soon as the indicator changes color, we know that neutralization has occurred. And this is where you want to stop the valve. Okay, so you're basically watching and you're waiting for the indicator to tell you, oh, we're neutral now, we're good. You added enough base to this acid to neutralize it. That's where you want to stop. Okay. Then what you do is you look at your burette and you see, okay, how much base did I have to add to neutralize my unknown concentration of acid? And then you record that volume. Okay, so we know 3 things, and I underlined them here. Right? We know 3 pieces of information already. We know the volume of the unknown, and let's call it an acid just to make it simple. We know the volume of the unknown acid, right? We can just measure that. We took a base that we know the concentration of, so we know the concentration of the base that we're using, right? That's a number. Concentration is a number as well. And we know how much of that base we had to add to the acid in order to neutralize it. All right, so we have 3 known numbers here. Volume of the acid, concentration of the base, and the volume of the base. And using those 3 things, we can actually figure out the concentration of the acid. Okay, now I'm going to walk you through how that's possible, but you don't have to know where this equation comes from. You just have to be able to use it. Okay, so this is a little bit extra, but I do want to show you where the equation comes from. So remember, what we're doing in neutralization, very simply, is we're combining H+, which is acid, with OH-, which is base, to neutralize it to get pure water. Okay, that's what's happening in a neutralization reaction, right? And since 1 mole, right, there's a 1 here, 1 mole of acid is needed to neutralize 1 mole of base, a nice 1-to-1 ratio, then the number of moles of acid and base, or H+ and OH-, must always be equal when neutralization occurs. Remember, that's why we stopped it at the neutralization. As soon as it changed color and became neutral, that's where we stopped, because at that point, the number of moles of H+ and OH- are equal. And that's going to be key for what we're going to do next. So, since at neutralization, at what we call the end point in a titration, which is where neutralization occurs, the number of moles of acid is equal to the number of moles of base. All right, keep that in mind for a second. We also know, okay, I know that a lot just popped up on your screen, just bear with me. This is just from the do now, right? Molarity is moles over volume. We knew that. So that means the molarity of the acid is the moles of acid over the volume of the acid, right? And if we rearrange that equation, we can move the things around, right, with that little bit of algebra. The moles of acid is equal to the molarity of the acid times the volume, right? That's just rearranging this equation that we looked at in the do now, the equation for molarity. so that we have moles of acid by itself, okay? Which we can do the exact same thing for the base, right? The molarity of the base is the moles of base divided by volume of the base. We rearrange it. The moles of the base is equal to the molarity of the base times the volume of the base, okay? Which means, right, because the moles of acid is equal to the moles of base, right, that means the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Okay, now, if you just rolled your eyes or looked away from the screen or let out a heavy sigh, that's fine. All you need to be able to do is use this equation. All right, I'm just showing you where it comes from, but really you just have to be able to use it. All right, so that's what the next part of the lesson is going to be. We're going to use this equation, which is still a little tricky, but you don't have to know where it comes from. I just wanted to show you that we don't just pull these equations out of nowhere. Okay? All right, so let's use this equation to figure out an unknown concentration. All right, so I'm going to be doing a lot of example problems here. So let's try this first one out. So if 50 milliliters, actually right now I'm gonna write down my equation and I'll go to my screen in a second here, right? So let me just look it up. Right, it's the molarity of the acid times the volume of the acid. This equation is in your reference table as well. Is equal to the molarity of the base times the volume of the base. All right, so that's good to know. So if 50 milliliters of KOH, now what is that, acid or a base? So it has the OH at the end, that's a base, okay? So 50 milliliters of KOH is needed to neutralize 200 milliliters of HNO3. Calculate the concentration of the acid. Okay, so pump the brakes real quick because remember that we're going to be using liters here. And I know I'm very annoying. I gave you all milliliters in these example problems, but we have to convert to liters. So when I write it down, I'm going to convert to liters. Okay, so again, 50 milliliters of base, KOH, is needed to neutralize 200 milliliters of, wait a second, you know what? There's missing information here, I just noticed. Let me fix that in real time. Okay, get rid of that. So if you notice, we got to have a concentration, right? We only have two numbers here. So let's make one up. I'm going to say, let's keep it simple. 1 molar KOH, all right? All right, that's kind of required. I'll make this 0.12. All right, sorry about that. All right, try that again. So if 50 milliliters of a 1 molar KOH solution is needed to neutralize 200 milliliters of HNO3, calculate the concentration of the acid. All right, now we can actually do this problem. Okay, so there's my equation, right? Now it said, remember, calculate the concentration of the acid. That's here. So this is what we don't know. So I'm just going to bring that down as a symbol because we don't know it. Molarity of the acid. Remember that the capital M stands for molarity. It's the concentration. So that it's going to be that times the volume of the acid, which was, remember, acid has the H in front, so that's 200 milliliters, which is really 0.2 liters. Okay? That's equal to molarity of the base. Let's look back. Okay, KOH, that's our base. The molarity is 1. That's easy. So 1. Okay? And maybe I'll put these in parentheses so it's easier to see. 1. And the volume of the base, 50 milliliters, which is the same as 0.05 liters. Okay? So with this equation, right, we have the three, it's always going to give you 3 of these terms, and you're always going to solve for the last one, right? So now it's just kind of a math thing, right? So to do this, I can do this out, right? 0.05 times 1, well, that's actually, I don't need a calculator for that. That's 0.05. And then if I divide both sides by, right, if I divide both sides by 0.2, that cancels that out. So I'm going to get the molarity of the acid is equal to, so that's 0.05, oops, let me show you, 0.05 divided by 0.2. 0.25. So the molarity of the acid is 0.25. Okay? And remember, that's moles per liter. That's what the molarity stands for. All right? So there's example number 1. Okay. Let me go back here. All right, let's do another one. Now this one's a little trickier, okay, and I will explain why. So I'm going to rewrite my formula that I know I'm going to need, right? Molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. And again, in your reference table, don't have to memorize it. Okay, so we have 200 milliliters of a 1 molar barium hydroxide solution. And if that was needed to exactly neutralize 100 milliliters of an HCl solution, what's the concentration of HCl? So we're actually solving for the concentration of the acid again, right? HCl is an acid. And don't forget, there is also a table in your reference table where it's the common acids and bases. So if you're not sure, it's going to be in there, and you can just look it up. Okay? So 200 milliliters of a 1 molar base. Okay? So let's get the 200. Let's get that information down. So the volume of my base was 200 milliliters, which is the same as 0.2 liters. Okay, you got to go to liters because molarity is in liters, right? Moles per liter. All right, so that's that. That's this number. Now, the concentration of the base here, this is tricky. So in a 1 molar solution of barium hydroxide, you're going to get 2 moles of OH, right? So up here, there was only 1 OH, but here there's 2. Look at the formula, OH in parentheses, 2. So this is actually, you're going to get 2 moles of base out of that. Okay, so the concentration of the base is actually 2 and not 1. All right, that's tricky. Okay. So now we need one of these numbers, right? And it gave us 100 milliliters of the acid, HCl solution. Okay, so, and that's going to be the volume of the acid, which is 0.1 liters, right? 100 milliliters is 0.1. And we don't know the concentration or the molarity of the acid. All right, so we're solving for the concentration of the acid again. Okay, so this time, right, we're going to divide this side by 0.1, which cancels that out. So it brings it over here. So now the molarity of the acid, in this case, I got to solve this. So we do 2 times 0.2, which is 0.4. And then I divide that by 0.1, which is 4. All right, so the answer there is 4. And the molarity of the acid is 4 moles per liter. Okay? So, let's see. Definitely look over that again. Remember, you have to look at the formula. Be careful, okay? If there's only 1 OH, like there is up here, just use the molarity that it says. But if there's 2 of them, you have to double it, okay? And it's never going to be more than 2 for our purposes, right? That's the only, extra little step. It'll only be 1 or 2. Right? So normally you can just use the same number, but you have to look. Also, careful of the acid, right? Remember way back, I'm going to go all the way back, in the do now, we were talking about this. A 2 molar sample of H2SO4 is 4 moles of acid or 4 moles of H+. So you have to check out the acid too. Make sure there's not a 2 next to the H, okay? Otherwise, you can just use what it says, like we did in our example problems here. Right? Okay. All right. So, time for you to try some of these on your own. Okay. Careful. One of these is normal, and you don't have to. It's an easier one, and one of them is a little more difficult. Okay. And then try that challenge question if you are feeling bold. All right. So hopefully you paused and tried those out, so you can check your work here. I'm just going to write my formula down. Right? Molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Cool. So we have 50 milliliters of a 0.1 molar lithium hydroxide solution. Okay, acid or base? It's a base because of the OH. All right, so 50 milliliters, 0.1 molar. Let's get that down. And this is the base, so I'm over on this side. So 50 milliliters is the same as 0.05 liters, and it was a 0.1 molar solution. Cool. That's that information down. Was used to completely neutralize 25 milliliters of acid, HCl again. And look at that, we're coming up with the concentration of acid again. Okay, so 25 milliliters, that's my volume of the acid, right? So that's 0.025. Sorry about how jumbled that is. Equal sign in there. Okay, and then we don't know the molarity of the acid. Okay, now I'm solving for the molarity of the acid again. I divide by 0.025, cancels that out. Divide by 0.025. Use my calculator here. So I'll do the top, 0.1 times 0.05 divided by 0.025. And that gets me the molarity of the acid is equal to 0.2. Okay, so hopefully you got this for an answer. All right, moving on to the next one. Remember, you can always pause, rewind, watch me do this again. All right, number 2 is a little more difficult. Hopefully you noticed the acid, right? You're going to have to double up the molarity because there's a 2 after the H, all right? And the base is okay in this one. All right, so I'm going to rewrite my formula just because, it's what we've been doing. The molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Okay, so we got 40 milliliters of a 0.1 molar H2SO4 solution. That's an acid, so this is the acid stuff, is needed to neutralize 100 milliliters of NaOH, which is the base. And it's asking for the concentration of the base this time. All right, so let's get this information down. 40 milliliters, 0.1 molar of acid. However, remember, H2SO4, so this is actually going to be 0.2 molar, right? That's what makes it tricky. 0.2 molar, right? If there's 2 H's, you got to double it up. If there's just 1 H, like HCl, it stays the same. 2 H's, you got to double it up. Okay. So 40 milliliters, 0.2 molar acid. Oops. Let's get that down. So it was 0.2 molar acid, and 40 milliliters is 0.04, and that's liters. Sorry about that. Okay, and I think it said we're coming up with the concentration of the base, so it must have given us the volume, which is 100 milliliters, which is the same as 0.1 liters. Okay, so now it's similar, except we're solving for this guy. So we wanted to divide this side by 0.1, cancels that out. Divide this side by 0.1, use our calculator, 0.2 times 0.04 divided by 0.1. So the molarity of the base is 0.08. All right, cool. So I know definitely a tricky lesson. Everybody gets stuck on math sometimes. There are more example problems in the reading I posted as well. Feel free to just go over the part of this video that does the math, totally fine, and then try out those homework questions to see if you really understand. All right, and if you want, stick around, and I'll do out this challenge question after I get a new piece of paper. Okay, so challenge question time. It says, propose 2 possible solutions, formula, molarity, and volume, that would neutralize 250 milliliters, so 0.25 liters, of a 3.5 molar solution of H2SO4. Oops, I wrote down 3.5 too soon because 3.5 molar solution of H2SO4 is going to give me double the amount of acid, so it's actually 7 molar acid. That's pretty dangerous stuff. So that's going to be 7 molar. All right. So it's asking for a solution of a base that would neutralize this, right? So if we have our equation here, molarity of the acid times molarity of the, I messed that up already, huh? Molarity of the acid times the volume of the acid is equal to molarity of the base times the volume of the base at neutralization. This is for our acid here, so the molarity is 7, and the volume is 0.25, okay? And that's going to be equal to whatever the molarity of the base times the volume of the base is. So let's do that out real quick. So 7 times 0.25, right? 1.75. So we're coming up with two possible solutions. So we need to come up with the formula, the molarity of the base, and the volume of the base, so that the molarity times the volume is equal to 1.75. So let's keep it simple. Let's pick two bases that are pretty simple. Let's do NaOH, and then we could do KOH. And I say these are simple because there's only one OH, so we don't have to worry about the the concentration changing between the number of OH ions and the molarity of the base in general. So, and then we could come up with a lot of things here, right? So basically, what two numbers, okay, multiply to get us 1.75? There's actually endless answers to this, right? I could say, let's make the molarity, let's make it simple for ourselves, 1.75 molar, and then 1 liter, right? Because 1.75 times 1 is 1.75. Or, and I'm going to take the easy way out here, we can make it 1 molar and have 1.75 liters, all right? Now, there are lots of other more difficult ways to do that. I came up with the easiest one because, let's make this video shorter, right? All right. If you came up with one and you want me to, check it to know, shoot me an email or drop in on office hours, and I'll definitely check your work on that. Okay. Cool. See you guys later. Oh, this is also the last lesson, right? So look out for the assessment coming on Monday.